Hello everyone. So today I am here to explain my Capstone Project 5, that is about applied statistics, in which we were given about 50 interview questions which we have to solve, and after that we have to explain 5 questions out of that in the video. So I have chosen 5 questions which will be explaining about my understanding regarding the statistics. And let's begin with our first question. So the first question is, what is the law of large numbers and how does it relate to probability theory? So the law of large numbers, uh, it is denoted by double N, that is the short form. It states that whenever the sample size increases, the sample mean will tend to close to the population mean. Means whenever we are increasing the sample size, the sample mean will be moving forward to the population means, but it will be more close. The value of the sample mean will be more close to the value of the population mean. That is, when we repeat the experiment multiple number of times and then we average the result, we will get the value that is close to the expected value. This is quite difficult to understand. So here I have taken a basic simple example of tossing a coin, through which we can understand the law of large numbers. So suppose we flip a coin for one time, then there is 50% of chance that we will get either head or tail. So 50% here is expected value, and the expected value means population mean. Now suppose again we flip the coin, but this time we are flipping it 4 times and we get one time head. So the probability of getting one time head will be 25%, correct? Now let's toss the coin for 100 times. And suppose we get 47 times head. So probability of getting head is 47%. Now again we are tossing the coin, and this time we are increasing the uh, number of times to be tossed to 1000. And suppose we get 543 head. So probability of getting head is 54.3%. So here we can see that as we are increasing our sample size, means that as we are increasing the number of tossing of the coins, that first it was 1, then 4, then 100 and 1000. As we are increasing our sample size, we are tend to approach to the 50%, that is population means, that it was first 25%, then 47, then 54, and it is close to the 50%, that is our population mean. So as we increase the sample size, our expected value also goes close towards the population. So this is the law of large numbers. Now, moving forward to the next question. How is confidence interval defined in statistics? So what is confidence interval here is, it is the range of the values within which we expect a particular population parameter like mean to fall. So it's a way to express that the uncertainty around estimate obtained from the sample of data. You should not misunderstand confidence interval with confidence level. These two are different terms. We will here understand confidence level also, so that we can not get confused between them. So confidence level is usually expressed as the percentage, that how sure we are that the true value lies within this confidence interval. And now let's understand with the example. Suppose you have a YouTube channel and there are number of subscribers you have, and the average age of those subscribers is between 25 to 32. So this range, this average age that you find out that it is between 25 to 32, this is the confidence interval. And the confidence level is 95%. Means that you are 95% confident that the average age is between 25 to 32. So Take another example. Suppose we calculate the 95% confidence interval for population's average height and we randomly select sample of 50 students. Then calculating their average height is 165 centimeter, for example, okay, and the result is in the range of 160 to 160, 170 centimeter. This suggests that if we were to take multiple samples and get confidence interval in the same manner, we should anticipate that approximately 95% of those intervals would contain the population's true average height. Now, I think with the help of these two examples, we can clearly understand what is the confidence interval and what is the confidence level. Now, let's move into the next question. What is difference between correlation and causation? So these are two different terms. So correlation means the relationship between the variables. So there can be positive relation, there can be negative relation, or there can be a zero relation. If one value goes up, then other value also goes up. If one value goes down, then other also goes down. Then that is called as the positive correlation. If one value goes higher and other goes lower, means both opposite, then that is negative correlation. And if no relation exists between them, then it is called as a zero correlation. Now let's understand the second term, that is causation. So causation here means that one variable directly influences the change in the another variable. Means that if one variable is changed, it will affect the other variable also. So there is the cause and effect relationship between them. But the correlation does not imply causation. It means that suppose if the correlation exists, either it is positive, negative, or zero, it does not mean that the one variable will cause change to the other variable. So let's understand with the example. Here I have taken the sales of ice cream and sunscreen. Okay, and it has been found out that there is a positive relation between. It means that if we plot a scatter plot, if we plot a scatter graph, we will find out that the sale of ice cream will increase. With that, the sale of sunscreen will also increase. So it does not imply that the sale in ice cream has caused that the sale in increase in the ice cream has caused people to buy sunscreen or vice versa. There is no relation between the ice cream sales and sunscreen sales. There is a third variable, that is summer weather, because of which the ice cream and sunscreen, both the products, the sales has increased. Now let's move into the fourth question. What is difference between descriptive and inferential statistics? So descriptive statistics and inferential statistics both are the two different type of statistical analysis. When we try to find out what is the mean, mode, variance, etc., and when we try to find the probability, then both these statistics are used. First, start with the descriptive statistics. So it is basically the collection, organization, analysis, and interpretation and presentation of data. So it focuses on summarizing and describing the main features of the data. Now, inferential statistics, it basically deals with the conclusion and predictions about the population. And in descriptive statistics, we use a measure of central tendency, that is mean, mode, median, and in the inferential statistics, we use probability, hypothesis testing, etc. to make the predictions. Now let's take the example. Suppose there is a class in which the test has been conducted and the students got the marks. So what descriptive statistics will here do is that it will give the information about the marks, that is average marks or range of marks, lowest marks, minimum marks, and the most common marks that the students has got. And what is inferential statistics will give here is it will predict the performance of the students based on these marks, that Suppose if the student has got 90 marks out of 100, so it will predict the performance of the students for the future tests. So it will give the predictions. More understand about the descriptive statistics and inferential statistics and the differences. So descriptive statistics gives the information about the raw data, which is that data in some manner, while inferential statistics means it means predictions about the population using data drawn from the population. Descriptive statistics helps in organizing, analyzing, and present the data in meaningful manner, while inferential statistics help us to compare the data, make hypotheses and predictions. Descriptive statistics is used to describe a situation, while inferential will what will do is that it is used to explain the chance of the occurrence of the event. Descriptive statistic will explain already known data and is limited to the sample or population having a small size. And inferential statistics, it will attempt to reach the conclusion about the population. Means the conclusion means basically the prediction. And in descriptive statistics, what we can do is we can create charts, graphs, and tables to understand the data in a very meaningful manner. And in the inferential statistic, what is can be done is that it can be achieved by using the probability. Now, the fifth question. Can two confidence interval with different widths have the same confidence level? So the answer is yes. The confidence interval with different widths can have the same confidence level. Width of the confidence level interval is affected by the sample size and the variability. A wider interval means more uncertainty, while narrow interval means better precision. Let's understand it with the example. Here I have used an example of catching a fish using two different nets, and both the nets have 95% chance of catching fish. So it means the 90% is the confidence level. Okay, so the both the nets have same confidence level, but here difference is that one net is wider and one net is narrower means both have two different confidence interval. So the nets are of different sizes, but both give the same level of confidence, that is 95% to catch fish. If net is wider, it means it will catch larger number of fishes, and with that it can catch larger junk also. But if the net is narrower, it will catch less fish and also the less junk. So here we can see that both the nets have 90% chances of catching fish, means the confidence level is same, but the confidence interval with and with the different width, that one is wider and one is narrower. So that's it. Thank you so much.